Welcome to The Explainer. Today we're going to shrink down, way down, to talk about the future of, well, every single electronic device you own.
For over half a century, our technology has been driven by this one simple rule. Just shrink everything. Relentlessly. Make it faster, cheaper, smaller. But that incredible era, the one that gave us everything from smartphones to supercomputers, well, it's about to hit a wall. And I mean a literal physical wall.
So, to really get a grip on where we're headed, we've got to first understand the fundamental limit we're slamming into. It's all about a so-called law that has basically defined the entire digital age.
Now, this isn't a law of physics like gravity or anything. It was really just an observation, a prediction that kind of became a self-fulfilling prophecy for the entire tech industry. It's been the engine of the digital revolution, right? Giving us exponentially more powerful and cheaper electronics year after year after year.
Okay, but here's the catch. The main technique we use, something called optical lithography, is, well, it's basically like using a stencil and light to carve circuits into silicon. But imagine trying to draw an incredibly fine, detailed line with a really thick marker. That's the challenge we're up against. We're now trying to etch features that are smaller than the very wavelength of light we're using to do the etching. It's getting ridiculously complex, insanely expensive, and honestly, we're just running out of room. All right, so if we can't just keep shrinking stuff with the old methods, what's next? What's the plan? Well, the answer isn't just about making things smaller anymore. It's about building them in a fundamentally new way. So, welcome to the world of nano. And let me tell you, this is a total game changer. We're not just carving out smaller and smaller components anymore. We're operating on a scale where the fundamental rules of physics, they just behave differently. At the nanoscale, quantum mechanics isn't some abstract theory in a textbook. It's literally the tool in your toolbox. And using this new toolbox, well, that unlocks some absolutely incredible advantages. First up, speed. I mean, pure, raw speed. See, at the nanoscale, electrons just face less electrical drag. You can think of it like unwanted friction or static. Engineers have a fancy name for it, parasitic capacitance. With less of that gunk in the way, devices can switch on and off at, well, just mind-bogglingly higher speeds. And then, of course, there's density. This is the one you'd probably guess, right? You can just pack an unbelievable number of components into the exact same space. That means tinier devices, sure, but it also means you're using less material, which cuts down on costs. And here's a big one, efficiency. Smaller circuits and shorter pathways mean less power gets wasted as heat. What does that mean for you? Well, it leads to dramatically more power-efficient devices. We're talking way longer battery life for your phone and a much smaller environmental footprint for all our tech. But maybe the most exciting part, the part that really gets the imagination going, is that working at this scale unlocks applications that feel like they're pulled straight out of a sci-fi movie. Seriously. But this isn't fiction. This stuff is just over the horizon, and it promises a whole new class of technology we can barely even dream of yet. Okay, so let's get into the nitty-gritty. How do you actually build something that's only a few atoms wide? I mean, really think about that. It turns out there are two totally, radically different philosophies for how to manufacture at this incredible scale. Think of it like this. You can be a sculptor or you can be a Lego builder. One method is about taking a big block and chipping away everything you don't want. The other is about starting with the tiniest possible pieces and building up. So you've got this top-down approach versus the bottom-up. For the last 50 years, the entire tech industry has been full of sculptors, right? Perfecting the art of carving away at silicon. But the future? Well, the future belongs to the Lego builders, the ones who don't carve away material, but who assemble our technology piece by piece, or really, atom by atom. Now, this whole builder approach, this bottom-up idea, it requires some revolutionary new Legos, And scientists are exploring all kinds of wild nanomaterials, from nanowires to quantum dots. But today, we're going to focus on one building block in particular that is really leading the charge. It's a material so amazing, it honestly sounds like it came straight out of science fiction. Okay, so picture this. You have a sheet of carbon atoms that's just one atom thick. It's called graphene. Now, imagine rolling that sheet up into a perfect, seamless little tube. That's it. That's a carbon nanotube. And the things these tiny tubes can do, they're simply astounding. Let me try to put this into perspective for you. Think about electrical current, the flow of electricity. These tiny, tiny tubes can theoretically carry a current density more than, get this, 1,000 times greater than a traditional copper wire. That's not just a little better, that's a completely revolutionary leap in performance. It's just a different league. So how in the world do you make these things? Well, you basically just vaporize carbon into this incredibly hot gas, a plasma. And then the magic happens. You're not mechanically rolling anything up, no tiny machines. In the chaos of that plasma as it cools down, the carbon atoms, they just build themselves into these perfect microscopic tubes. It's a stunning, beautiful example of that bottom-up Lego builder manufacturing in action. And this is why they're so incredibly promising. I mean, look at this list. They're ridiculously strong and lightweight. They can handle extreme temperatures. And here's the real kicker. Depending on the exact angle you roll that sheet of graphene, a nanotube can act either like a metal wire or like a semiconductor, the very heart of a transistor. You can build all the different parts of a circuit from the same basic stuff, and that stuff is carbon, one of the most common elements on the entire planet. All right, so where is all this actually going? What's the end game? Let's take a look at how these wonder materials are already being used to build the incredible devices of tomorrow. And I want to be clear, this isn't just theory anymore. Researchers are building this stuff right now. Okay, first up, logic gates. If you replace the little silicon channel inside a transistor with one of these carbon nanotubes, you get something called a CNTFET. These are the fundamental building blocks, the on-off switches for future computers. And they have the potential to be just vastly smaller and faster than anything made of silicon today. And it's not just about processing either. It's also about memory. Companies are already developing new kinds of memory, like nano RAM, that use a tangled web of these nanotubes to store data. This could create super high-density storage that's also non-volatile. That's a fancy way of saying it holds on to your data even when you turn the power off. Think about that. This could one day replace every kind of memory we use in all our devices. And it just keeps getting cooler because these things operate at a molecular scale. You can use nanotubes and nanowires to literally detect specific individual molecules. This just blows the door wide open for incredibly sensitive biosensors that could be built right into our electronics. We're talking about a revolution in medicine and diagnostics. You know, this idea that we could build computers using molecules, it was first talked about way back in the 1970s. For a long time, it sounded like pure fantasy, but it's not a fringe theory anymore. It is now the driving force behind an entire field of research. It's become the roadmap to a future that pushes us way beyond the limits of silicon. And that really is the ultimate promise here, a future where we finally stop being sculptors and we start being builders. A future where our technology isn't just smaller, but it's fundamentally smarter, more efficient, and assembled from